Figure of merit of a galvanometer. The galvanometer is a device used to detect feeble electric currents in a circuit. It consists of a coil suspended between the poles of a powerful magnet. As current passes through the coil, it deflects. It can be detected from the deflection on galvanometer needle. The deflection is proportional to the current passed through it. The galvanometer coil has a resistance of about 100 ohm. The current required to produce a deflection of one division in the scale of galvanometer is known as the figure of merit of the galvanometer. Here, we use the half deflection method to determine the resistance of a galvanometer and then its figure of merit. Materials required: galvanometer, battery eliminator, 2 resistance boxes of values 5000 ohm and 500 ohm, 2 one-way keys. Principle: when a galvanometer is connected in series with a cell via a resistance box of high resistance, the current flowing through the circuit I is equal to E divided by R plus G, where E is the EMF of the cell, R is the resistance from the resistance box, G is galvanometer resistance for current I. The current flowing through the galvanometer is proportional to the deflection in it. I is proportional to theta, or I is equal to K theta. Theta is galvanometer deflection for current I. K is figure of merit of the galvanometer. When a shunt resistance S is introduced parallel to the galvanometer, the current flowing through the circuit is I prime is equal to E divided by R plus GS by G plus S. If I is adjusted so as to reduce the galvanometer detection to half, I prime is equal to K into theta by 2. Then the resistance of the galvanometer can be calculated by using the relation G is equal to Rs divided by R minus S. When current I produces a deflection theta in the galvanometer, then its figure of merit is calculated as K is equal to E divided by R plus G into theta. Procedure: to find the resistance of the galvanometer, arrange the components on a table and connect them as per the connection diagram. The positive end of the cell is connected to the high resistance box R and its negative end is connected with one end of the galvanometer via key K1. The other end of the galvanometer is connected to the high resistance box. A shunt resistance S is connected in parallel with the galvanometer through key K2. After the connections, introduce a high resistance in the resistance box R and insert the key K1. Adjust the value of R so that the deflection in galvanometer is maximum. Note the deflection as theta. Now, insert the key K2 also without changing the resistance R. Take out a small resistance from the resistance box S. Adjust the value of S so that the galvanometer deflection reduces to exactly half the value obtained without shunt, that is theta by 2. Note the value of shunt resistance S. We can repeat the experiment by changing the value of high resistance R and in each case note the shunt resistance needed for half deflection. The resistance of the galvanometer can be calculated each time by using the relation G is equal to Rs by R minus S. To find the figure of merit of the given galvanometer of resistance G, construct the circuit as per the connection diagram. Insert the key and take out a high resistance from the resistance box. Note the deflection theta in the galvanometer for the resistance R. Repeat the experiment for different values of R and note the corresponding deflection in galvanometer. The figure of merit of the given galvanometer can be calculated each time from the relation K is equal to E divided by R plus G into theta.